And welcome back. Now today we're going to be talking about the nRF24L01 Plus modules, like this one here, and indeed that one there and that one over there, which are currently talking to each other. And they're all connected to a blue pill, like that one at the back. That's an STM32F103. And yeah, it's all working quite nice on my little adapter board. There's one at the back there that's working, and whoops, and there's one over there as well. Now funnily enough, the two I've just pointed out are not originals. One's a GD32, I think the other one's a CKS32, but whatever, they're running just fine. And yeah, now why am I doing this then? Because I get so many questions about the Arduino version of this video, which was great. It sets it out nicely to transmit a single character backwards and forwards. But I do get a lot of questions. The main question we'll be answering in this video a bit later on. But first we'll have a message from our sponsor who makes this video possible in the first place. I'd like to give a shout out to LCSC Electronics, China's leading electronics components distributor, who are in fact sponsoring this video. Our electronic components orders can be picked and shipped in just 4 hours, and you can pay by PayPal, various credit cards, American Express, or even wire transfer. And you don't even have to create an account if you'd prefer not to. Just check out as a guest on their easy to use website. If you do decide to create an account though, you can use their new feature of account prepaying. I think I might try that soon. Try out their website now. Right, straight on with the nitty gritty then. These two Arduino, I said Arduinos, they're not. They're these two STM32s are talking to each other via the nRF24s. What are they actually saying? Well, let's flip over to the code window quickly and have a look. Right, here we are. That's one of the sketches, but what you want to see is the bit behind my head actually. The red is the transmitter, okay, over here, and the black is the receiver. And I've made the messages really short and a little bit terse, and I've also had to put quite a few delays in just so that we didn't get interleaved messages. These devices are quick. What happened was that the transmitter was trying to send a message out onto the serial window here, and it'd get halfway through the message and the receiver unit would have already received the RF transmission and would also be sending stuff back, and you'd get the bits muddled up on the same line. It's absolutely madness. So I thought this is useless for a demo. Let's slow things down. So what's happening now is the transmitter sends out a packet and then it waits. The receiver receives the packet and waits a little bit. Then it says, I've got it, this is what I've got, and now I'm going to send it back slightly modified, and then the transmitter again says, oh yes, I have received a reply, this is what I got. And that's what you're seeing exactly on the screen now. So if I just stop this, so it stops going off the top of the screen every 2 seconds. Right, so what we're saying here, look, the transmitter is saying I've sent out 169, the value in a byte, and I've got an auto acknowledgement from the device I'm sending it to, which means the receiver has said, I've received something, and I'm just telling you I've received it. And then the receiver says, right, what I actually got when I read that message was 169. That's good because that's what the transmitter sent out. And it says I'm going to add 1 to that and send that value back. So it sends the value back to the transmitter, and it also says I've got an acknowledgement now from the other side that they have actually received it. And then the receiver is quiet because the transmitter then says, oh yes, I sent out 169 and I got back 170. So in its entirety, that proves every single stage of what's happening. Now, when I said auto acknowledgement, that's an optional parameter you can switch on, and basically it ensures that any one of these NRFs, when it sends something out, how do you know it's been received by the other side? After all, it's not a broadcast like a radio transmission, you know, from a disc jockey. I mean, they don't care whether you receive it or not. Whether you receive anybody tunes in, they don't care. They transmit regardless. But here, we most definitely really would like to know, if I transmit a number from here, I'd like to know that the corresponding receiving end has actually got it. And then it can do what it likes with it. So for example, if one of these units were in a greenhouse, say, transmitting the temperature, when it sends it back to the master unit and says, okay, this is the temperature this hour, you want to know that it's been received, not so it's just lost in the ether. So the auto acknowledgement will come back from this device to this one to say, yes, got it. Now what it's not doing at that point is saying, yes, I got this particular value. Now you can switch on the payload to come back, but I haven't gone that far. That's just one step too much. I think the very fact that it says, yes, I've got a value, be assured you don't have to resend that, and then it does some work here, I think is probably good enough. And indeed, that's the way the Arduino sketch that I wrote worked, and very reliable it was too. And when this does something with that data, in this case it just adds 1 to that value it gets, when it sends it back to this one here, this one auto acknowledges the fact that it got something from here. It says, yeah, I've got something. I don't know what I've got, but I know you sent me something and it's currently in my buffers. So that's great. Now, this one here in the middle, by the way, with a bit of paper on it so I can easily identify it. That one was plugged into here not 15 minutes ago. And it's been running all night, probably closer to 24 hours actually. So this one here and this one here have been sending stuff backwards and forwards all that time. And then 15 minutes ago, this one decided it didn't want to play anymore. It got bored and it's just dead in the water. Won't do anything. So I had to dig another one out. Thank goodness I had some others. And this one's started to play very nicely now. So we'll take this one away and maybe I'll look at it to see if there's some sort of soldering fault. But the thing is, it actually stopped on my workbench as I was doing some distance testing. Just stopped. So I don't quite know what I'm going to do about that one, but let's hope reliability isn't an issue. As I say, it's been running for 24 hours pretty much non-stop. Okay, let's have a look at the sketch then. Now it is a little bit changed on what the Arduino sketch was, but the principle's there pretty much. So we'll whiz through it and then we'll talk about the other question I get asked an awful lot. Okay, right, here we are then back in the code, and yeah, it's chuntering on there. So what I'm actually going to do is stop that so it doesn't distract us. I'll just freeze that. Right, so the code then. Now this is the transmitter one, which is obviously identified by the TX at the top. I'll put that in a couple of places because the sketches are so similar it's easy to get mixed up. Now the very first thing you have to do is change the library that we were using. We were using RF24. In fact, it says it looks still in the comment there. RF24, that's the Arduino applicable library. We need a new library called RF24-STM. So I've dug that out and plugged it in, and then of course we need to change the pins that it runs on. So the pins we need to connect up to this time when we invoke the object of RF24 and create whatever name you want. I've called it radio. This time we're connecting it to PB0, probably marked up as B0 on your board, and PA4, probably marked up as A4. Okay, all this is documented, don't worry. Now, originally in the Arduino, I've just left this in for historical interest really. This is how we connected up the two nodes. We gave them two names like this, 1 node and 2 node, although the first digit had to be a number, but the second bit, it didn't really matter. And then these funny long address, basically a 64-bit address. Now I've stopped doing that this way because I had quite a few questions about this and do we really need to do this and all that, so I've tried to simplify it. So we'll ignore that and I'll show you how we've done it in the setup. So okay, we start the radio object up, we set the power level up. Now you can use PA min rather than PA low. Now minimum really is minimal and it's good for testing with because it doesn't suck much power in, which is what I used in the Arduino, but this time I've been playing about, and PA low works as well, but you're not going to get much more than a few meters of distance between the two items. I'm also running at 2 megabits. 2 megabits is great if you've got a good signal path, but if it's a bit dodgy then you really need to drop down to 1 megabit. And there's a very long range version for 250 kbs. Incidentally, if your nRF24L01 Plus does not do 250 kbs, it just doesn't work, then you've probably got a clone, and we'll talk a lot more about that at the end of the video. Now the channel is anything from 1 to 125. Just choose one that's unlikely to be used by your Wi-Fi. Unfortunately, I've changed this to 104 because I was experimenting a bit. That probably is being used by Wi-Fi actually, and given that my router's only about 4 foot in that direction, I'm surprised it's working at all. Okay, so it is working though. Here you can optionally tell it how many retries to make if it doesn't succeed getting that auto acknowledgement initially. I've said every 200 milliseconds you can have up to 50 tries. Well, I was just playing about, as I say. You probably wouldn't want 50 tries. Now, here, this is the bit that's changed then. So whereas previously we were doing it like this and people got all confused about what the array was, I'm just hard coding a hexadecimal value. You have a single pipe which you're transmitting down, and then the other device is reading that pipe. Now there are 6 pipes available, but the first pipe is going to be shared. Avoid pipe 0. Okay, it's just too confusing. So you've really got pipes 1 through to 5. And both sides use the same pipe. But the hexadecimal address that you use on each of them has to be switched, a bit like the TX-RX on one of these USB to serial converters. And it doesn't matter what value you use here, although the actual code requires a 64-bit address, you can use anything. Now I've used B3, B4, B5, B6 because they must be the same for all 6 channels. Okay, and then the last bit, which I've got as 01 or 02, is the bit that makes them unique. And you'll see this in the receiver side, that we just switch these addresses round. So whereas we open the reading pipe here on 01, on the other side we'll open the reading pipe on 02, and the writing pipe here on 02, it will be 01 on the other side. Auto acknowledgement, as I say, it's an optional feature you can have. I've set it on because, as I say, it's a useful feature to have. Otherwise, how do you know that the transmission's ever been received? You might think, well, I don't really care too much. A bit like UDP, you know, you send it out. If somebody receives it, well, great. If not, doesn't matter. Well, I think it does matter if you're in a greenhouse or a beehive or whatever it is, you're sending out all that data. You probably want to know, don't you, that it's been received. Otherwise, what you're doing there, you could be transmitting all day long and nothing's ever been received. So I've set the auto acknowledgement on, which is a slight change to the original plan. I thought that was set on by default, but here I seem to had to actually set it on for it to work. We might have to dig a bit further for that. This is a new function here. We can do the print details. So if we just look at the debug window over here, the serial monitor, if I reset the receiver, there we are, look, and freeze it. So this bit here tells you everything there is to know about what that receiver RF24 thinks it's doing. So data rate, it says there's 2 megabits, great. I'm a model nRF24L01 plus, but then it would say that, wouldn't it? The power level is PA low, that's great. That's the enable auto acknowledgement, and it's got 3F in there, but we don't have to worry about the value as long as it's not 0, which means switched off. That's good. And the address we're sending out on, look, that's the one we just talked about on that reading pipe. Yeah, that's probably about all we need to know on that, but you can have a look at that in your own time. Right, and what we're doing here, of course, we're getting a random value to send out. It's just a 1-character value we're sending out to the other side. Why 1 value? Well, if you can't send 1 value, well, 1 byte of data and send it back again, then there's something seriously wrong, isn't there? So rather than trying to send the Encyclopedia Britannica in one go, and you're limited to 32 bytes, don't forget, per packet, we might as well start small. Okay, right, let's have a look at the loop code and see what that gives us. Right, here we are in the loop. So first of all, we stop listening, which you have to do before you can send anything. Even if you're not actually listening, you still have to invoke that particular method. We're just getting the value here to transmit. Here we're saying what we're about to send out. This is the important bit for auto acknowledgement. If not radio write, that means if it didn't come back with a response, something went wrong. But if you switch it off, auto acknowledgement, it will always be true. Okay, so your code won't break if you suddenly switch it off. However, this is the bit that makes people stumble, that bit there. Now what's that doing? It's saying, well, I'm sending out the data and it needs to be a reference to the data, not the data itself. So you need that ampersand in front of it. And then you give it the size of the data you're sending. Well, we're sending the size of 1 byte. So yes, we could have put in 1 there, but 1 is a bit of a magic number. Let's make it obvious what we're sending. We're sending the size of the data, which is 1 byte. And you'll see in the next sketch why that is important. It then just says whether or not we got an acknowledgement, and then it says, right, now I'm going to start listening for a reply. Now when I say reply, we've already had a reply, haven't we, in terms of the auto acknowledgement, but this is the reply now from the slave receiver, because that's going to send us some data back. Okay, so now we say, right, we just grab the time, grab the millis time, because we don't want to wait forever. So what it's saying here is, this little loop here, is that I'm going to wait for a maximum of 250 milliseconds, quarter of a second. More than enough time, believe me. This thing works in microseconds. Well, we are talking, radio waves, so it takes absolutely no time to transmit. And these processors are fast. So quarter of a second, 250 mil is more than enough. Now, if it doesn't get anything back in that time, it will just say, I've sent out a particular value, 10, but I didn't get anything back. And it will just wait then for 2 seconds before it tries again. Now let's assume that it did get something back. It says, okay, let's define that as a byte, because we know it's going to be 1 byte coming back. And go and read that value. Once again, a reference to that data. This one here is a reference with the ampersand in front. And how big is that data we want? Well, once again, it's the size of 1 byte, which is 1. Then we just send out a little message here. I'm going to let you read that in your own time, frankly. This is just better than using lots of serial.write statements, serial.print statements. It's basically saying, I sent out this and I've got this back. Okay, sprintf, it's one of those commands that C++ users use all the time, and you really should try and get to grips with that. It's really easy to use. There's a buffer to which all the formatted string gets put into. I've declared one here. Well, I've called it 100 bytes. I didn't know how long it's going to be, but it's certainly not going to be 100 bytes. Then you put the string that you want to display in there, and this is where you need to look it up on the internet. I'll put a link on my video description down below and in the GitHub to say I've got a decimal value here and I've got a decimal value here. What are those decimal values then? Well, one of them's the data, which is going to be put in as an integer. Remember, although it's a byte, it's not numeric, but I'm saying it is in this string. So it's an integer of data and an integer of the received data. And then we just do a serial print with a small delay there, as I say, just to let things happen nicely in sequence. And then finally, we have a delay of 2 seconds, just so that we don't get hundreds and hundreds of these things streaming off that you couldn't see. I've deliberately slowed this right down. And in a real life scenario, of course, if your greenhouse is transmitting the temperature, humidity, dew point, whatever, it's not going to be doing it every 10 milliseconds, is it? It'll do it perhaps every hour, every half hour, but certainly not several times a second. So at least that delay doesn't actually make this sketch unrealistic in that sense. Okay, so that's the transmitter. What's the receiver code like? Very, very similar. Let's have a look. Right, this is the receiver sketch now, the slave receiver, okay? So the slave literally just sits there all day long waiting for something to arrive. Okay, if nothing arrives, it says nothing. But when it arrives, it will say, yeah, I've got this. I'm going to add one to the count and then send it back and then sit there again forever. So let's just have a look at the code very, very quickly. It's very similar to the last time. Here's your 3 includes, the same as last time. Oh, here's a little bit of documentation about which pins you need to connect to on the blue pill. Okay, and I've even put the color code of the DuPont cables here in my code, just to stop all those questions as well. Use the same DuPont cable colors that I have, and then you'll be able to see from the video, the extra photos that I'm going to put up there, exactly what connects to what. Okay, right, we start up the radio again, exactly the same as last time, and then hit the setup code. That was the old code from last time. We're not looking at that. So the setup, very similar to last time. Doing the begin, power level the same. So obviously it has to be the same speed, it's not going to communicate. Has to be the same channels, it won't communicate. Oh, here, funnily enough, I've said you can only retry 5 times, not 50. Bit mean, but there we are. Now this is the bit here, look, that changes. On the last sketch, you notice the reading pipe was not 02, it was 01, and the writing pipe was 02.01. We've just swapped those around, but the pipe number is the same. Number 1, do not use pipe 0. Use 1, 2, 3, 4, 5. And if you need any more, you're in a bit of a mess really, because trying to use more than that, you can create what's known as a radio mesh, but that's well beyond the scope of this video, and please do not ask me questions about that. Okay, so we start listening, set the auto acknowledgement to true, and print out the details in exactly the same way. Okay, let's have a look at the loop and then see what difference there is, if any. So here's the loop. All it does is say, right, here's my byte of data that I'm expecting to receive, and it just goes around this big if statement to say, if there is a radio transmission available to me. If not, it just falls through the bottom. Look, there's the end of that if statement, and it keeps whizzing round basically. But having found that yes, there is a transmission available, it then goes and reads it immediately. In the previous sketch we had a while radio available. We're not doing that this time because funnily enough it didn't work that well, and I don't know why. What happened was the if statement said yes, you have got radio data. The while then said no, you haven't. So I don't know if there's a mistake in the library, and radio available actually goes and reads it, clears the buffer so that the while no longer gets it. I don't know, but we don't need it anyway, thank goodness. We just read whatever's been sent, small delay, print out, yes, I got that data there, which is what we're seeing over here. Look, got 37 for example. Then we have to stop listening because we do want to send something back in a minute. So we stop listening, increment the data value. So in this case, we got 37. We're going to increment it to 38. And then it says, I'm just about to send this. And we do. And once again, it's a reference to that data. Once again, size of a single byte. And if we don't get the acknowledgement, it will say, I didn't get an acknowledgement. If you do, we'll get the RX-ACK, which is what we do here, RX-ACK. And then it says, now I'm going to start listening for the next packet. Really, really simple stuff. Okay, and as you see, if I release the scroll lock on here, it's still running quite well. And if I get out of the way a little bit, there we are, you'll see it running quite nicely. Okay, so that seems to be working well, doesn't it? Now, on my workbench, of course, these things are only positioned, what, 3-4 inches, 100 millimeters apart. I mean, it's no distance at all. So I did go down the bottom of the garden this morning with the transmitter and left the receiver running this end just before it stopped working, funnily enough, and just to see if it would transmit from probably about 10 meters away on low power. And here's a quick snapshot of what I got. Cool. Now, on to the next question that everybody asked me about that previous video that I did so long ago. They go, I've got it working, great, your video is fantastic, yeah, good stuff, but how do I send more data? I don't just want to send 1 byte, I want to send 36.47 as a temperature, for example, or a humidity value of 94.368. How do I do that? I can't figure out how to work out how to do it. Very, very easy. Coming up next. I've uploaded the 2 new programs. They're just modifications, very simple modifications, the 2 you've already seen. But this is the critical bit that I think a lot of people will be interested in. So let's switch over to the code. Here we are. Now already you can see over in this part of the window, the debug serial monitor, that I'm sending a lot more data. For example, there's an ID, temperature, maximum temperature, humidity, dew point, bee count, maximum of bees, and all of those are different data types, just to show how we can do it. Okay, one thing you don't ever want to send to, by the way, are strings. What does a string mean? There is no meaning to a string. Even if you were to send, I don't know, high or low, you don't want to send a string. You want to send a 1 or a 0 or a 6 and a 10, whatever meaning it has. Do not send strings. Strings just take up all the room. There's absolutely no point in doing that. Keep it to numerical data types, and you'll have a see why in a minute. Right, let me just bring this down there. We don't need that anymore. Right, so the way we do it then is to create something called a struct. Now a struct is short for the word structure, and we give it a name. Now this is a data definition. It doesn't actually create an actual thing that you can use in your program yet. This is more like a blueprint. Okay, this is a description of how your data is put together. So what we're saying here is I've got a signed integer of temperature, and yes, all integers are signed unless you put unsigned in front of them. But the question is really, should we not put signed in front of them to make it absolutely clear we expect a signed value here? Because if you never go below 0, why are you using a signed value? It might as well be unsigned. You get a much bigger data range. In fact, if you look at the comments for that one, it's 2 bytes long. A signed value goes from minus 32,000 to plus 32,000. But if we look at the next one, which is an unsigned, and I've missed out the word int because that's inferred by convention, I suppose. 2 bytes, 0 to 65,535. So you can see the range is a lot bigger. Now we can have a double and or a float. Now you might think, well, hang on, are they the same? Double precision or a floating point variable? Well, on the Arduino, the AVR platform, they're the same, 4 bytes. And on the STM, they're 4 bytes as well. On the Due, for example, they're 8 bytes long. So that's a bit different, and the precision will be quite high, wouldn't it? You can get 64 bits of precision there. But here, it's a 32-bit floating point, and I've even made a note there. Look, the double is the same as the float. Now remember that floating point is always a bit dodgy in maths because you will lose precision depending on how many decimal places you go down to. If it's just 1 or 2 and the values are not particularly big, so for example for temperature 34.8, 68.9, absolutely no problem. You start putting in, furnace type temperatures, 18,496.84196, and try and subtract, multiply, divide, you might lose precision. But for this sort of work, we're absolutely fine. There's also a long, which is also 4 bytes. Now signed means it will go from minus 2 billion to plus 2 billion, and unsigned long, which I've got for my maximum number of B's in my B count, it goes up to 4 billion. Great, I think that's big enough. I'm not going to have that many B's down there. And finally, just a little byte again that we were using. I thought, well, let's keep that in there just to show you that we can still do this, and it's 1 byte long. So that makes up, this bit here makes up a total of 21, and you can have a maximum of 32 bytes. Do not exceed that because you will not be able to transmit more than 32 bytes in a single packet. What happens if you do want to transmit more than 32? Now, if you've got 4,986 bytes to transmit, I'm guessing this is not the right solution for you, right? But if you've got, say, 40 bytes and that's it, and you want to transmit those, well, you can transmit those in 2 lots of 20 or 1 lot of 32 plus 8. But of course, the logic of your program has to be that I'm transmitting 1 lot, and then you have to acknowledge that. Then I'm transmitting another lot, and you get auto acknowledgement of that. Then the receiver has to do the work. Not particularly difficult, but just think about whether there's a different solution. Maybe a 433 megahertz transmitter and receiver is a easier solution. In fact, that's what I use for Benny's cat run. I just use a 433 transmitter, and it works absolutely fine for temperature, humidity, whether he's out there or not. Simple stuff. Okay. So having created this blueprint called data, we're now creating an actual instance of it here. So it's not an int, it's not a string, it's not a double, it's a data, which you've defined up here called my data. So this object now will contain room for each one of these here. And that's how you can get all this data into one single transmission. Okay, now if we look at the setup is going to be very similar, except what I do is just put some values in there initially, just so we've got something to look at, which you can see over here. Okay, and then with the radio begin and all that is just the same, no different there at all. Then we come on to the loop, and the loop says, I'm sending out a reference to my data. Now remember, it's got the ampersand in front of it because it doesn't need that reference. And this time we say it's the size of my data, not a byte. Obviously that's one. My data, even if you don't know how big it is, but as long as you know it's less than or equal to 32 bytes, it's just size of my data, whatever that is. And then you can adjust that size without having to constantly come back here and change the size. Okay. So once again, you get the acknowledgement. Hello. I think Amazon Echo is trying to talk to me. Exactly the same. Blah, blah, blah. Yes, I'm waiting for a reply. The reply line is the same in that I'm receiving the data now, size of my data, and then we're going to print it out. And that print is exactly what you're seeing here, because this is the master transmitter we're looking at. So it transmits it out, the receiver gets it, changes a couple of values, and then it comes back. And it does that every 10 seconds or thereabouts. And it all comes back absolutely fine. You can see there's no corruption there. What it does, it adds one, I think it is to the temperature. Yeah, they're at 74, came out at 73, add one to 74, and the humidity goes up by 0.1. So it went out as 50.47, comes back as 50.57. All right, it's probably up to about 60 now. We've been talking so long. And that's it. So the receiving side is very similar. Once again, you've got that documentation in there. Setup, no different from the initial one because there's nothing to do with that data initially. And the loop just says, go and get me that data with that special size now. And this is that instance of the struct that you've created. It says I've received it. Here's what I've received. So in black up here, that's what that is. Okay. And then it just says, increase the temperature by 1. Oh yes, increase the max B's by 1. Let's see if that worked. 234,568, 234,569. Whoa! Yeah, complicated stuff, eh? And the humidity, as I said before, goes up by 0.1. And then it just transmits that data back again, waits for the auto acknowledgement, which it says, yes, I've got it there. And then it starts listening again for the next packet to come down the line. Easy stuff. Okay, so that's all pretty easy, yeah, and this is still running. If I flick back to the code, you'll see behind my head this thing going up every 10 seconds. I've made it every 10 seconds, just that it didn't keep scrolling off the screen. Now it just went there, didn't it? That's fine. So what could possibly go wrong? Quite a bit, as it happens. Yeah, would you believe it? First of all, as I said, this device suddenly stopped working after hours and hours and hours of working absolutely fine. Now, how do you know whether or not you've got a kosher Nordic nRF24L01 Plus? Do not buy the non-plus versions because they are inferior. They can't do 2 megabits, for example. I don't think they can do 250k either. And the range is poorer. So do get the plus version, even if you're offered the non-plus cheaper. It's just a false economy, really. So the question, going back to the question, how do I know this is genuine or not? And the answer seems to be, having done some serious research on this, is that the one you have and that I have here are probably all fakes, or at least clones. Now, they would be clones if they didn't say they were Nordic, and these don't. They just say nRF24L01s, which I guess they're allowed to do. I'm not quite so sure. But anyway, they're nRF24L01s, and they're almost certainly clones, apparently. Now, I've had these ones, though, for quite a few years. And in fact, there's a date code on here that says it was manufactured in 2014. Probably about the time when I got them, actually. So maybe I was lucky and I just got originals. I don't know. It does work. All of them work. I've got about, I think I bought a pack of 10, actually. They all work at both 2 megabits, 1 megabit, 250 kbs, and the auto acknowledgement works. If you cannot get the auto acknowledgement working, or it doesn't work at 250 kbs or 2 megabits, then either you've got an nRF24L01 without the plus bit on the end, or you've got a fake that just can't do that sort of thing. Okay, so that's a clear indication. Now, there's also things on the internet about, the writing on the chip. Should it be of this font or that font? Well, it's not quite that clear cut, because Nordic are a fabless company. That means they do not have any fabrication processes themselves. They farm it out to all these other factories that can produce them and then get them back in and send them out to resellers. So you can't really tell if they're exactly the right ones or not, because each factory will be slightly different. Yeah, so I think what they're saying is if you buy from a reputable reseller, for example, names that I can think off the top of my head, RS Components, Mauser, Farnell, or Element 14 as they're known now, big places like that, I don't think they're going to be knowingly stocking fakes. And of course you can always ask them, you know, how can you guarantee that these are the right product? And they'll say, well, first of all, the price will tell you that, because you can't get 10 of these for like $2 or something ridiculous. Okay, they're not cheap if you get the right thing. And then they will work 100%. That said, these clones, I'm assuming these are clones, I don't know, but if they are clones, these work very well as well. Even on low power, I could get to the bottom of my garden, which is what? Less than 10 meters away, and it worked absolutely fine. So if they work, then they work, don't they? Although that one there stopped working, it would appear. So maybe they're not quite so reliable as you might think. Anyway, I'm going to put some interesting links for you to read down the bottom and on my GitHub. All right, and it's always worth going to the GitHub first, really, because everything that you can read down there will be on my GitHub, plus everything else that I can put up there, and I can make it up there in my GitHub look a bit nicer. I can put pictures on it and highlight things and different colors and what have you. So it's always worth going to the GitHub. Okay, what I'm going to also do is ask you to please, if you can, look at the links down in the video description. Have a look at any sponsors down there like LCSC, who would appreciate you looking around their website just to see what they got. Let's hope that everything is okay in China at the moment, or with their terrible weather. And yeah, if you think this video is worthwhile, give it a thumbs up. Remember that the sketches and everything will also be in the GitHub and links down below. And yeah, okay. Thanks for watching. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.